Across the globe, hidden beneath veils of mist and silence, lie sprawling, waterlogged landscapes, mysterious realms that quietly shape the fate of our world. These are the bogs, the fens, the moors, the ancient peatlands, where water and earth merge in a delicate, timeless embrace. While they may lack the towering grandeur of rainforests or the vibrant spectacle of coral reefs, peatlands possess a quiet, enduring majesty all their own. They are nature's silent sentinels, working ceaselessly to maintain the balance of life on Earth. For thousands upon thousands of years, these saturated worlds have been at work, unseen and uncelebrated, weaving a tapestry of life and elemental cycles that sustain the planet. Deep within their spongy soils, layer upon layer of ancient plant material accumulates, forming peat, a dense carbon-rich archive that locks away the breath of millennia. Each season, each year, each century adds a new chapter to this living record, as mosses and sedges grow, die, and are slowly transformed beneath the water's surface, untouched by decay. In the quiet corners of these wetlands, where dew clings to emerald moss and the air is thick with the scent of earth and water, the true magic of peatlands unfolds. Sphagnum moss, the architect of the bog, forms a living carpet that soaks up water like a sponge, creating a world where only the most specialized life can thrive. Though peatlands cover just 3% of the Earth's land surface, their influence is vast, stretching across continents in a patchwork of green and gold. Within this seemingly modest expanse, they hold a secret power. Twice as much carbon as all the world's forests combined, locked away in their depths, safe from the atmosphere. This feat of natural engineering is achieved not through speed or spectacle, but through patience and persistence, as water and moss conspire to slow the passage of time itself. Each layer of peat is a page in the story of the Earth, preserving the memory of ancient climates, vanished forests, and the slow march of evolution. Yet this balance is fragile. The bog's surface, ever shifting and soft, is a testament to the delicate equilibrium that has persisted for ages. Within these watery worlds, life has found a way. Carnivorous sundew plants glisten with sticky droplets, ready to trap unwary insects, while rare birds nest among the mossy hummocks, their calls echoing across the open expanse. Every creature, every plant is a specialist, perfectly adapted to the acidic, waterlogged conditions that would challenge most forms of life. The bog acts as a vast living sponge, absorbing rainfall and slowly releasing it, filtering and purifying water as it moves through the dense mat of moss and peat. Growth here is measured not in days or weeks, but in centuries. Mosses creep forward, millimetre by millimetre, building the bog ever higher, ever deeper. Yet even in their isolation, these ancient landscapes are not immune to change. Storms, droughts and shifting water levels test the resilience of the bog, challenging its ability to endure. When the balance tips, the bog's surface can dry and crack, exposing the ancient peat to the air, where it slowly releases its stored carbon back into the sky. The fate of these unseen guardians hangs in the balance, their future uncertain as the world around them shifts. If the bogs falter, the consequences ripple outward, touching every corner of the biosphere, as ancient carbon is set free and the climate's delicate balance is disturbed. But when they thrive, peatlands are a force of nature, resilient, enduring and vital, quietly sustaining the world in ways few ever see. To journey into the heart of a bog is to step into a world where time slows, where every drop of water and every blade of moss plays a part in a grand, ancient design. Here the smallest details reveal the greatest truths, the resilience of life, the power of patience, and the profound interconnectedness of all things. Let us now delve deeper into these remarkable places, and uncover the secrets held within the silent, steadfast guardians of our planet. Deep within the tapestry of the natural world, there exist landscapes that quietly shape the fate of our planet, peatlands. But what are these mysterious places and why are they so vital? At their core, peatlands are a unique type of wetland, where the passage of time and the presence of water combine to create a realm unlike any other. Here, the decomposition of plant material is profoundly slowed, as if nature herself has pressed pause on the cycle of decay. Picture a world perpetually saturated, where water seeps and pools, filling every crevice and hollow. In this waterlogged domain, oxygen is scarce, and the usual agents of decay are held at bay. When plants such as sphagnum moss, sedges and shrubs reach the end of their lives, they do not simply vanish into the earth. Instead, their remains linger, preserved by the ever-present moisture, resisting the fate that befalls most organic matter in forests or meadows. These remnants become waterlogged, their transformation into soil halted, leaving them only partially decomposed, a process that is both ancient and ongoing. Over centuries and then millennia, these layers of organic matter accumulate, one atop another, forming a dense, dark, spongy material known as peat. Each layer is a chapter in the story of the land, a record of seasons and centuries gone by. The growth of peat is a slow and patient process, with new layers forming at a rate of just 1 millimetre per year. Over thousands of years, this gentle accumulation creates vast reserves of organic material hidden just beneath the surface. The secret to peatland's extraordinary ability to store carbon lies in this very process. Each layer of peat is a vault, locking away the carbon that once flowed through the veins of living plants. Through photosynthesis, mosses, sedges and other wetland plants draw carbon dioxide from the air, weaving it into their tissues as they grow and thrive in the gentle sunlight. In most ecosystems, when a plant dies, its carbon is released back into the atmosphere as it decays, continuing the endless cycle of growth and decomposition. But in peatlands, this cycle is interrupted. The waterlogged conditions slow decay to a crawl, trapping the carbon within the peat where it remains for centuries, even millennia. The roots and stems of mosses and sedges become entombed in the dark, cool depths, their carbon locked away, unable to escape into the air. Layer upon layer, the peat thickens, forming a sealed archive of ancient carbon, hidden from the world above. This is why peatlands are known as carbon sinks, vast, silent guardians that draw carbon from the air and store it deep within the earth, a service they have provided for over 10,000 years. Peatlands are found across the globe, from the frozen tundra of Siberia and Canada, where icy winds sweep over endless white expanses, to the mist-shrouded moors of Scotland and Ireland, where rolling bogs stretch beneath brooding skies. In Finland, peatlands are a defining feature, covering nearly a third of the land and weaving through forests and lakes in a patchwork of green and gold. Yet peatlands are not confined to the cold. They flourish in temperate zones where gentle rains and mild climates nurture their growth. In the tropics, immense peat swamp forests stretch across Indonesia and the Congo basin, their tangled roots and dense canopies sheltering some of the world's deepest stores of ancient carbon. Each peatland is unique. Some are open, sunlit bogs, others are shadowy swamps beneath towering trees. Yet all share the same remarkable trait, the power to capture and hold the carbon that shapes our world's climate. Collectively, peatlands form the largest terrestrial carbon store on Earth, their reach spanning continents and climates. After the vastness of the oceans, peatlands are the planet's second-largest carbon reserve, a silent force with staggering influence. It is estimated that global peatlands hold over 600 billion tons of carbon, a quantity that defies imagination. To grasp the scale, consider this. Peatlands store more carbon than all the world's forests combined, including the mighty Amazon, the vast Congo, and the endless boreal woods of the north. These are nature's true carbon vaults, silent, enduring and steadfast. For millennia they have kept their treasure hidden, quietly regulating the climate and preserving the delicate balance of life on Earth. In the vast northern latitudes of our planet, many of these great peatlands are frozen solid. This permanently frozen ground, known as permafrost, has acted like a planetary freezer for thousands of years, keeping the immense stores of carbon within the peat locked in a deep icy slumber. These permafrost peatlands, stretching across Siberia, Alaska and northern Canada, are true giants of the carbon world. They hold an astonishing amount of organic material, a legacy of ancient vegetation that has been preserved in the ice. For as long as the ground has remained frozen, this carbon has been stable, inert, and safely sequestered away from the atmosphere where it could cause harm. But our world is warming at an unprecedented rate, and the Arctic is warming 2 to 3 times faster than the global average. This rapid temperature rise is causing the permafrost to thaw. The planetary freezer is failing. As the ice that has bound the soil together for ages melts, the ground softens and collapses, and the ancient organic matter within the peat begins to awaken. For the first time in millennia, microbes can access this long frozen material and begin the process of decomposition. This awakening is not a quiet one. It is a process that releases powerful greenhouse gases into our atmosphere. When thawing permafrost peatlands become wetter, as is often the case, the microbes that thrive in these low oxygen conditions produce methane. Methane is a particularly potent greenhouse gas, over 80 times more powerful at trapping heat than carbon dioxide over a 20-year period. If, however, the thawing ground dries out, different microbes take over, and they release the stored carbon primarily as carbon dioxide. In either scenario, the result is the same. The carbon that was safely locked away for eons is released into the atmosphere, adding to the greenhouse effect and creating a dangerous feedback loop. The more the planet warms, the more the permafrost thaws, and the more greenhouse gases are released, which in turn causes even more warming. This process transforms these ancient carbon sinks into new and potentially vast carbon sources. The thawing process is complex, involving a delicate interplay of temperature, moisture and microbial activity. As the ice melts, the once stable peatlands become dynamic landscapes, releasing carbon in various forms, each with its own impact on the climate. The release of methane and carbon dioxide from these thawing peatlands is a slow, steady and significant addition of greenhouse gases, a new flow of carbon into our atmosphere that will make the challenge of stabilizing our climate even greater. This is a slow, steady and significant addition of greenhouse gases, a new flow of carbon into our atmosphere that will make the challenge of stabilizing our climate even greater. The transformation of the Yamal Peninsula is a story written in ice, soil and silence. A tale where the land itself becomes both witness and participant in a drama millions of years in the making. In the heart of the Siberian Arctic, the Yamal Peninsula stretches out beneath a vast unbroken sky. Here the land is shaped by ancient forces, relentless winds, biting cold, and the slow, patient work of permafrost that has locked secrets beneath the surface for millennia. During a summer of unprecedented warmth, the permafrost, once a fortress of frozen earth, began to yield. The ground softened, ice crystals wept into rivulets, and the soil, long held in a frigid embrace, turned to mud and waterlogged pools. From the mist and fog that clung to the melting ground, the land exhaled ancient breath. The air grew heavy with the scent of peat and secrets, as if the earth itself was whispering stories long forgotten. The tundra, once a tapestry of moss and lichen, began to change. Grazing fields that had supported herds for generations became barren. their surfaces scarred by the retreat of ice and the advance of water. Across the landscape, the remains of ancient creatures preserved in the permafrost for centuries were revealed. Bones and hides, once hidden, now lay exposed to the elements, silent witnesses to a time when the world was colder and the land was untouched. The permafrost, acting as nature's vault, had preserved these relics in icy stasis. As the ground thawed, these remnants of a vanished world emerged, their forms slowly surrendering to the warmth and moisture of a changing climate. Pools of water gathered in the hollows, seeping into the soil and carrying with them the essence of ages past. The land, once solid and unyielding, became a mosaic of mud, water, and ancient organic matter, blending the present with the distant past. The sky above, often painted with dramatic clouds and shifting light, seemed to brood over the empty expanse. The landscape, stripped of its usual rhythm, stood as a sombre reminder of the forces at work beneath the surface. Within the layers of ice and soil, the permafrost held more than just the memory of cold. It was a living archive, storing ancient microbes, bacteria and viruses, some dormant, some waiting for the right conditions to awaken. As the ice receded, these microscopic mysteries were released, flowing with the meltwater, seeping into the earth, and mingling with the new life that now called the tundra home. Rivers and streams, once frozen solid, now wound their way through the landscape, carving new paths and connecting pools of meltwater. The ground, fractured and patchworked, revealed the intricate web of life and history beneath its surface. Even the air itself seemed to carry distant echoes, currents of warmth and change that had travelled from far-off lands, bringing with them the energy that would reshape the Arctic forever. The thawing permafrost became a crossroads of natural forces, where climate, ecology and geology converged. The land was no longer just a backdrop, but an active participant in a story of transformation and uncertainty. Each change set off a cascade of effects. Melting ice led to flowing water, which in turn altered the soil, the plants, and the very chemistry of the land. The tundra became a living demonstration of nature's interconnectedness. As the sun dipped low on the horizon, casting long shadows across the peninsula, the ice continued to break apart. The land seemed to speak in creaks and drips, a message from the depths of time. Invisible yet potent, greenhouse gases rose from the warming ground, joining the haze and fog that drifted across the tundra. The air shimmered with the energy of change, hinting at forces both seen and unseen. The meltwater, rich with minerals and ancient elements, flowed over the land, carrying with it the legacy of eons. Heavy metals, once locked away, now mingled with the streams, entering the cycles of life anew. Deep fissures opened in the permafrost, revealing dark hollows and layers of soil untouched by sunlight for thousands of years. Each crack was a window into the planet's ancient history, a Pandora's box of ecological mysteries. The Yamal Peninsula stands as a silent sentinel, its vastness echoing with the lessons of the past. Here, the land itself warns of the delicate balance that sustains life, and the profound consequences when that balance is disturbed. To truly grasp the intricate dance between a nation and its peatlands, one must look to a land where these ancient wetlands shape the very fabric of the environment. Here, in the north, peatlands stretch across the landscape like a living tapestry, their presence woven into the story of the land itself. In this Nordic realm, bogs and mires dominate nearly a third of the terrain, more than anywhere else on Earth relative to its size. These wetlands are not just features of the landscape. They are the landscape, forming a vast, interconnected network of water, moss and soil. For millennia, these landscapes have existed in quiet equilibrium, their rhythms dictated by the slow accumulation of peat, the gentle rise and fall of water, and the silent cycles of growth and decay. These are places of stark, haunting beauty, where wild cranberries and cloudberries nestle among mosses, and the only sound is the whisper of wind across open water and the hush of ancient silence. Beneath the surface, these peatlands hold one of the nation's greatest treasures, a colossal storehouse of carbon, quietly accumulating since the retreat of the last ice age, layer upon layer, year after year. Yet, over the past century, the fate of these wetlands has shifted dramatically. The landscape, once governed by the slow hand of nature, has been reshaped by the relentless pursuit of economic growth and resource extraction. Across the land, networks of straight lines now cut through the bogs, drainage ditches that channel water away, lowering the water table and transforming the once saturated ground. Water, once held in the embrace of moss and peat, is drawn away, exposing the land to the air and altering the delicate balance that has persisted for thousands of years. The transformation is profound. Soggy, oxygen-poor peatlands become drier, firmer ground, their ancient waterlogged soils now exposed to the elements, their character forever changed. More than half of these peatlands have been drained, creating a patchwork of altered and untouched landscapes, a mosaic that tells the story of a nation at a crossroads. When the water recedes, the peatland's essential function is reversed. The process that once locked away carbon now releases it. The lush green of living moss gives way to the brown of drying peat, and the slow, steady capture of carbon is replaced by a rapid, relentless release. Exposed to oxygen, the peat decomposes swiftly, releasing its ancient stores of carbon into the atmosphere as carbon dioxide, a reversal of millennia of natural sequestration. What was once a powerful carbon sink, quietly absorbing greenhouse gases, becomes a significant carbon source, its legacy transformed. On a global scale, emissions from drained peatlands rival those from aviation and deforestation, their impact stretching far beyond the borders of any one nation. In this land, the altered peatlands now stand as the largest single source of greenhouse gas emissions, a stark reminder of the consequences of past choices. The landscape itself stands at a crossroads, a meeting point between the legacy of the past and the promise of a different future. Across the wetlands, silent instruments now measure the pulse of the land, tracking water levels and the slow movement of carbon, searching for ways to restore balance. In places like the Ranskala forest, experiments unfold quietly. Water tables are adjusted and the land is observed, seeking the delicate threshold where emissions can be curbed and the ecosystem can begin to heal. By carefully managing water levels, raising them just enough to slow decomposition, but not so much as to disrupt the fragile balance, there is hope for dramatically reducing emissions and restoring the land's ancient function. The lessons learned here ripple outward, offering guidance to other lands where peatlands lie at the heart of the carbon cycle. This is the search for a new equilibrium, a future where the land's silent guardians can once again lock away carbon, repairing the wounds of the past and safeguarding the climate for generations yet to come. Among the most extraordinary features of peatlands is their unparalleled ability to preserve the story of the natural world across millennia. In these waterlogged, acidic environments, the process of decay is slowed to a near standstill. This unique chemistry transforms bogs into living archives, where the passage of time is recorded layer by layer, undisturbed for thousands of years. Each stratum of peat is a chapter in the Earth's own diary, capturing the subtle shifts in climate, the rise and fall of plant communities, and the echoes of ancient ecosystems. By carefully extracting a core from the bog, scientists can peer back through time, reading the story written in the compressed remains of mosses, sedges, and other wetland plants. The deeper the core, the further back the record stretches, sometimes revealing uninterrupted environmental history spanning more than 10,000 years. Within these ancient layers, the remains of plants are preserved in astonishing detail. Mosses, leaves, and even delicate stems retain their structure, their colours sometimes still vivid after centuries in the dark. Microscopic pollen grains, trapped in the peat, reveal the changing tapestry of vegetation. By analysing these grains, researchers can reconstruct the forests and meadows that once surrounded the bog, tracing the ebb and flow of plant species as climates warmed and cooled. Fossilised seeds, leaves, and entire plant stems are uncovered, each a clue to the bog's botanical history. These remnants allow scientists to piece together the story of how plant communities adapted to shifting rainfall, temperature, and atmospheric conditions. By comparing the layers of peat with other climate records, researchers can see how bogs responded to ice ages, droughts, and periods of abundant rainfall, offering a window into the resilience and vulnerability of these ecosystems. The story preserved in peat is not limited to plants. Layers of dust, volcanic ash, and even traces of ancient wildfires are locked within the bog, each marking a moment of environmental upheaval. These layers of ash and dust serve as time-stamped signatures, allowing scientists to pinpoint distant volcanic eruptions or periods of increased atmospheric dust and to track the movement of natural pollutants through the ages. By mapping these events, researchers create a detailed timeline of environmental change, linking the story of the bog to the broader history of the planet. Sometimes the preservation is so complete that entire plant communities from thousands of years ago can be reconstructed, offering a glimpse into vanished worlds. The intricate details of mosses, sedges, and other wetland plants are frozen in time, their forms unchanged by the centuries, providing a living museum of botanical evolution. These natural archives are not just collections of ancient plants, they are records of entire ecosystems, preserved in perfect detail for future generations to study. The ability to read these ancient records is a powerful tool, allowing scientists to understand how ecosystems have responded to past changes and to anticipate how they might adapt in the future. By integrating the lessons of the past, researchers can refine climate models, predicting how peatlands will respond to the challenges of a warming world. Will these ancient landscapes continue to thrive, drawing down carbon as new plants flourish in warmer, wetter conditions? Or will the balance tip and the slow release of stored carbon accelerate, transforming these time capsules into sources of greenhouse gases? The answers to these questions are inscribed in the ancient layers of peat, waiting to be uncovered, silent witnesses to the ever-changing story of our planet's natural world. While much of the world's attention is drawn to the thawing peatlands of the north, an equally urgent and often overlooked crisis is unfolding in the tropical peatlands of Southeast Asia, Africa and South America. These ancient waterlogged forests are not only among the most carbon-dense ecosystems on Earth, but also sanctuaries of extraordinary biodiversity. Within these lush, shadowy forests, life flourishes in remarkable abundance. Towering trees, their roots submerged in dark, peaty water, form a dense canopy that shelters a world teeming with rare and specialized species. For millennia, these forests have quietly accumulated deep layers of partially decayed wood and plant matter, creating a unique, spongy soil that locks away carbon and nurtures a web of life found nowhere else. These peatlands are colossal reservoirs of carbon, holding vast quantities that, if released, would have devastating consequences for the global climate. But their value extends far beyond carbon storage. Tragically, these vibrant ecosystems are under siege. The relentless encroachment of deforestation and drainage is fragmenting the once continuous forests, leaving behind barren scars where life once thrived. As native forests are replaced by monotonous monocultures, the intricate tapestry of life unravels. The loss of habitat spells disaster for countless species, rare orchids, amphibians and elusive mammals, each uniquely adapted to the waterlogged, acidic conditions of the peat swamp. Deep canals, carved through the heart of the forest, drain away the lifeblood of the peatland. The water recedes, exposing the carbon-rich soil to the air and setting in motion a chain of irreversible changes. The once saturated peat dries and cracks, and the lush vegetation withers. The delicate balance that sustained this ecosystem for thousands of years is shattered. As the peat is exposed, it begins to decompose rapidly, releasing enormous quantities of carbon dioxide into the atmosphere. The air shimmers with the invisible exhalation of ancient carbon, a silent warning of the consequences of disturbance. But the peril does not end with decomposition. The dried-out peat becomes a tinderbox, its brittle surface ready to ignite at the slightest spark. Fires, once rare in these waterlogged forests, now rage with terrifying intensity. The dried peat smoulders underground, burning slowly and relentlessly, hidden from view. When these fires erupt, they consume not only the surface vegetation but also the very soil itself, releasing centuries of stored carbon in a matter of days. Unlike surface fires, peat fires can smoulder underground for weeks, months, or even years, creeping through the dried-out organic soil and leaving devastation in their wake. The smoke from these fires is thick and acrid, blanketing entire regions in a toxic haze that chokes the sky and blocks out the sun. A single peat fire can release more carbon dioxide than millions of cars would in a year, turning the peatland from a carbon sink into a carbon bomb. The dense haze drifts for hundreds of miles, transforming vibrant landscapes into ghostly silhouettes and disrupting the delicate rhythms of life for all creatures that depend on the forest. In some years, the emissions from burning peatlands have rivaled those of entire industrialized nations, sending shockwaves through the global climate system. The relentless destruction of these peatlands threatens not only the climate, but also the survival of countless species, each one a thread in the intricate fabric of the ecosystem. Scientific models paint a sobering picture. As the planet warms, decomposition in these tropical zones is expected to accelerate, further amplifying the release of greenhouse gases. The warming climate hastens the decay of plant matter, turning once stable peatlands into sources of carbon and threatening the survival of the unique species that call them home. Projections suggest that by the end of this century, the carbon released from degrading and burning tropical peatlands could outweigh all the carbon being absorbed by healthier peatlands in the north, tipping the global balance. If this tipping point is reached, these ecosystems will shift from being guardians of the planet's carbon to powerful engines of global warming, creating a feedback loop that accelerates climate change and imperils the rich biodiversity that depends on these ancient, mysterious forests for survival. Across the world, vast stretches of peatlands lie scarred and wounded, their surfaces cracked and dry, their once lush carpets of moss faded and thin. These damaged bogs, though battered, hold within them the quiet potential for renewal, a promise that, with time and the right conditions, nature can heal itself. The first and most vital step in bog restoration is to protect the remaining untouched peatlands. These rare sanctuaries, where water pools among vibrant mosses and ancient peat layers lie undisturbed, serve as living blueprints for what damaged bogs can become once more. Shielded from the threats of drainage and development, these intact bogs quietly perform their ancient work, storing carbon, filtering water, and nurturing a web of life uniquely adapted to their saturated world. The secret to their resilience lies in the delicate balance of water and life. When this balance is maintained, the bog's surface remains spongy and alive, locking away carbon in layer upon layer of slowly accumulating peat. For bogs that have been drained and damaged, restoration begins with the return of water. The landscape is gently coaxed back to its natural waterlogged state as pools and channels fill, and the water table rises to embrace the land once more. Artificial ditches and canals, once carved to drain the life from the bog, are blocked and sealed. As water is held back, the bog's thirst is quenched, and the slow, patient process of resaturation begins. Small dams, crafted from peat and moss, become guardians of the rising water. Behind them, the land softens and the ancient rhythm of the bog resumes, water seeping, moss swelling, oxygen fading from the depths. As the peat becomes saturated, the invisible process of preservation takes hold. Without oxygen, the decomposition of ancient plant material slows to a crawl, and the relentless release of carbon dioxide is halted. Over months and years, a quiet transformation unfolds. Mosses, especially the remarkable sphagnum, begin to recolonize the wet surface, their tiny leaves drinking in water and sunlight, weaving a living tapestry of green. These mosses are the architects of recovery. As they grow, they draw carbon dioxide from the air, building new layers of peat millimetre by millimetre, year after year. The bog surface becomes a cradle for specialist plants, sedges, cotton grass and insect-eating sundews, each one adapted to the wet, acidic world. Sphagnum mosses in particular are the unsung heroes of restoration. Their ability to hold many times their weight in water keeps the bog saturated, while their slow decay forms the very peat that locks away carbon for millennia. As the mosses flourish, the bog's ability to absorb and store carbon is restored. The land, once a source of greenhouse gases, becomes a powerful carbon sink, quietly helping to cool the planet. In time, the revived bog teems with life. Dragonflies dart above the pools, frogs hide among the moss, and rare birds return to nest in the safety of the wetland. The ecosystem, once broken, is whole again. Across continents, these natural processes repeat, from the misty moors of Scotland to the tropical peatlands of Indonesia. Each restored bog is a testament to nature's resilience and the intricate dance of water, moss and time. Restoration is not always simple. Some bogs, choked by shrubs or scarred by past disturbances, recover slowly. Yet even here, the patient work of water and moss can, over decades, bring new life. Where bogs border forests or fields, the restored wetland forms a living boundary, filtering water, supporting biodiversity, and offering a buffer against floods and droughts. In some places, new forms of wetland-compatible vegetation take root, thriving in the saturated soil and contributing to the bog's slow recovery. These plants, adapted to the wet, acidic conditions, help stabilize the ecosystem and support a diversity of wildlife. The journey of restoration is long, measured not in months or years, but in decades and centuries. Yet with each passing season the bog grows stronger, its layers thickening, its waters deepening, its life returning. Every hectare of restored bog is a triumph of nature's quiet persistence, a living, breathing archive of the past and a vital promise for the future. In the patient, silent work of water and moss, the planet finds hope and the climate finds a powerful ally. We have journeyed into the quiet, waterlogged worlds of our planet's peatlands, where time moves at the pace of moss and water, and the air is thick with the memory of millennia. Here, in these ancient landscapes, nature has woven a tapestry of life and decay, of growth and rest, in a cycle that has quietly shaped the fate of the earth. From the frozen edges of the Arctic, where permafrost locks away secrets of the past, to the trembling surface of the tundra wetlands, the bogs hold stories written in layers of peat, stories of ancient forests, vanished climates, and the slow, patient work of mosses building the land beneath our feet. In the tropics, where fire and water wage a silent battle, the peat forests breathe out their warnings in plumes of smoke, their roots clutching the earth in a desperate embrace. The message is unmistakable. The health of these overlooked ecosystems is bound to the rhythm of the planet itself, their cycles echoing in the stability of our climate and the promise of the future. Bogs are not mere bystanders in the story of the Earth, they are the silent engines at its heart, orchestrating the slow dance of carbon, water and life. Each sunrise over a bog signals the continuation of a process that has endured for thousands of years, a process of absorption, transformation and renewal. The fate of the bogs now hangs in a delicate balance, their future teetering on the edge of change, as natural cycles are disrupted and ancient patterns are threatened. If the cycles of water and carbon are broken, if the bogs are drained, burned or thawed, their ancient stores of carbon will awaken, shifting from silent guardians to restless adversaries. The land, once saturated and alive, becomes parched and fractured, its memory of water fading as the cycles unravel. The soil, once a cradle for life, smoulders and seeps, releasing what it has held for ages into the air, feeding a feedback loop that accelerates change. As warmth seeps into the ground, the bogs exhale, their breath thick with the carbon of centuries, amplifying the warming that first disturbed them. The cycle spirals, each turn bringing more heat, more release, more unravelling of the ancient pact between land and sky. In this future, the bogs, once allies in the fight for balance, become sources of instability, their power turned against the harmony of the world. Yet the story is not yet written in full. There is another path, one where the cycles of nature are honoured and restored, where the bogs are allowed to heal and thrive. In this vision, every untouched bog and moor is a sanctuary, a living archive of the planet's resilience and wisdom. Restoration becomes a natural process. Water returns to the land, mosses reclaim the bare ground, and the slow work of healing begins anew. The wounds of the past are covered by new growth, the cycles of water and carbon re-established, and the bogs resume their ancient role as guardians of balance. As water rises and ditches are blocked by the hand of nature itself, the transformation is profound. Carbon once destined for the sky is drawn back into the earth, and the bogs become sinks once more, quietly absorbing and storing what the world cannot afford to lose. The bogs purify water, filter the air, and nurture a web of life that flourishes in their embrace. Countless species find refuge in the mossy labyrinth, their lives intertwined with the fate of the peat. This is not a distant dream, but a reality that unfolds wherever the cycles of nature are respected and allowed to flourish. The responsibility, then, is not a burden but a call to stewardship, to honour the ancient pact between land, water and sky. To protect and restore peatlands is to participate in the great cycles of the earth, to become part of the story of renewal and resilience. These landscapes are among the most powerful and cost-effective allies in the quest for planetary balance, their quiet work sustaining the world in ways both seen and unseen. The gift of a thriving bog is a legacy that endures, a promise kept for all the cycles yet to come. By honouring the guardianship of these ancient lands, we take a step toward a future where the world is stable, vibrant and whole. The bogs, in their quiet persistence, invite us to join in the stewardship of the Earth's most vital cycles. For millennia, the bogs have served as the planet's silent sentinels, holding the balance of life and climate in their spongy embrace. Now, as the sun rises on a new era, it is time to honour their service and ensure their cycles continue for the sake of all life that depends on their quiet strength. In the heart of the bog, water begins a journey unlike any other, a journey sculpted by mosses, sedges, and the patient accrual of peat. Here, rain does not simply fall, it is welcomed into a world where every drop is cherished, filtered and transformed. As the clouds weep onto the spongy landscape, the water is drawn down, slowed by the dense mat of living and ancient plant matter. Each layer, soft, tangled and rich with centuries-old secrets, acts as a sieve, catching sediments, trapping impurities, and allowing only the purest essence to seep through. Within the labyrinthine channels of the bog, water is not rushed. It lingers, meandering through a maze of moss and organic debris. Along this path, minerals are exchanged and nutrients are cycled with exquisite care. Acids produced by sphagnum moss lower the pH, creating an environment where only select forms of life can thrive, and where contaminants are neutralized or buried deep within the peat. The water that emerges from this process is transformed, softened, cleansed of excess nutrients, and freed from the burdens it carried from the outside world. The bog is more than a filter, it is a regulator, smoothing the peaks and valleys of the water cycle. When rain is abundant, the sponge-like peat swells, holding vast reserves of moisture, slowing the rush of runoff and tempering the threat of floods. In times of drought it yields its stored bounty, drop by precious drop, sustaining streams, rivers and wetlands far beyond its mossy borders. The steady release of water ensures that life downstream persists, even when the sky withholds its gifts. Mist rises from the bog's surface, a gentle exhalation that carries moisture back to the sky. This vapour joins the wind, seeding clouds and guiding the return of rain. In this way, the bogs orchestrate the dance of precipitation and evaporation, weaving themselves into the great hydrological cycle that sustains the world. Their influence reaches far beyond their boundaries, shaping the flow of rivers, the clarity of lakes, and the rhythm of seasons. Within these ancient wetlands, water is not merely stored or released, it is transformed, purified, and set upon a course that supports all who depend upon its journey. The bogs, in their quiet persistence, are the silent architects of water's path, sculpting purity from chaos, balance from abundance and scarcity. Through their unseen labour, the cycle of water is renewed, and the world is kept in delicate, life-giving harmony. Beneath the surface of the bog, a secret kingdom thrives, an ancient community bound by adaptation and resilience. Here, in the cool, acidic embrace of the peat, life has unfolded in unexpected forms, each species a testament to the power of persistence. The sphagnum moss, soft and spongy, forms the very foundation of this world. Its tiny stems and leaves are capable of holding up to 20 times their weight in water, creating a living carpet that floats atop pools and hollows. This moss not only engineers the landscape, but also acidifies its surroundings, shaping the destiny of every creature within. Nestled among the moss, the sundew waits, its leaves glistening with droplets that mimic morning dew. But these beads are sticky traps, designed to lure and ensnare unwary insects. In a land where nutrients are scarce, the sundew has traded roots for cunning, digesting its prey and drawing sustenance from the sky. Nearby, the bog rosemary unfurls its silvered leaves, coated in tiny hairs to ward off the chill and conserve precious moisture. Its pale pink blossoms rise above the moss, inviting pollinators that have learned to navigate the tangled undergrowth. In the still dark waters, the carnivorous bladderwort floats, rootless and free. Its tiny bladders, like miniature traps, snap shut at the slightest touch, capturing water fleas and mosquito larvae in a silent ballet of survival. Each capture is a fleeting victory, fueling the plant's growth in a world where the soil gives little. Moving with careful grace atop the peat, the moor frog reveals its secret. In spring its skin flushes a brilliant blue, a signal to attract mates among the sedges. Its eggs, laid in gelatinous clusters, will become tadpoles that must grow quickly before the waters recede with the changing seasons. Dragonflies patrol the air, their iridescent wings flashing in the filtered light. They hunt with unerring precision, keeping the mosquito population in check, and serving as prey for the watchful bog turtle, which glides silently through the shallows. The turtle's domed shell is a shield against predators, while its webbed feet are perfectly suited to the soft, yielding ground. Below the surface, the peat is alive with springtails, mites and worms. These tiny decomposers break down fallen leaves and stems, releasing nutrients that fuel the next generation of moss and sedge. Even fungi have carved out a niche, weaving delicate threads through the peat, forging partnerships with roots and recycling the dead. Every inhabitant of the bog is linked in a delicate web, each adaptation a response to the challenges of water, acidity and scarcity. Together, they create a world where resilience is the rule, and every life tells a story of survival against the odds. Within this hidden realm, the bog's flora and fauna are not just survivors. They are innovators, shaping and reshaping their world with every breath, every bloom, every silent hunt beneath the mist. Long before the first trees reached for the sky or the earliest birds took flight, the story of the bog began, etched into the very bones of the earth. Millennia ago, as glaciers retreated from the last great ice age, they gouged deep scars across the landscape and left behind vast hollows and shallow depressions. These basins, filled by meltwater and rain, became the cradle of the earliest peatlands. With the world's climate in transition, a slow and silent transformation unfolded. Hardy mosses, led by the indomitable sphagnum, crept across the waterlogged ground, weaving a living tapestry atop the cold, mineral-rich earth. In these new wetlands, the air hung heavy with moisture, and the sun's warmth struggled to penetrate the dense, mist-laden air. Here, the slow dance of accumulation began, each season's growth pressing gently onto the last, trapping ancient leaves and stems in a cool, acidic embrace. Over centuries, the build-up of peat thickened. Layer upon layer the bog grew, sometimes just a millimetre each year. In places where the water table stayed high, the process was glacial, locking away the remains of vanished plants and the echoes of forgotten seasons. These layers became a living record, a natural archive chronicling the rise and fall of ancient forests, the sway of climate, and the steady, unhurried pulse of the earth. As eons passed, bogs adapted to shifting climates and evolving landscapes. Some spread outward, conquering new ground with their mossy advance. Others retreated, succumbing to the encroachment of forests or the drying breath of warmer winds. In the tropics, peatlands arose in the shadow of ancient deltas, where rivers deposited silt and plant debris in tangled masses, creating floating carpets of life and decay. Through every epoch, the bogs have been shaped by elemental forces, water, ice, fire and time. Lightning strikes ignited surface fires, scorching the uppermost peat but leaving the deeper layers untouched, preserved in a smouldering slumber. In colder times, permafrost locked the peat in an icy grip, halting decay and sealing away the secrets of ancient worlds. Today, the bogs endure as living relics, each one a silent witness to millions of years of change. Their depths hold the memory of vanished glaciers, the rise of forests, and the relentless march of seasons. Within their layers, the geological history of our planet is written not in stone, but in the quiet persistence of moss and water, echoing the patient artistry of time itself. Beneath a canopy of mist and moss, a silent process unfolds, one that shapes the very breath of the planet. In the stillness of peatlands, every droplet of water, every tangled root and every decaying stem participates in a delicate exchange. Here, The choreography of life and decay does not simply sustain the bog itself. It reaches far beyond, weaving invisible threads into the fabric of the global climate. Each season, mosses and sedges stretch upward, drawing energy from the sun and carbon from the air. As they flourish, they capture carbon dioxide, one of the atmosphere's most potent greenhouse gases, and weave it into their living tissues. When these plants die, their remains settle gently onto the saturated ground. In the waterlogged embrace of the bog, where oxygen is scarce and decay is slow, a transformation begins. Instead of returning swiftly to the sky, the carbon is locked away, layered and preserved in the cool, acidic depths. Over centuries, this quiet process creates a vast reservoir. A vault where ancient carbon is stored, safe from the cycles of fire and drought that release it elsewhere. Peatlands, though covering just a small fraction of the Earth's surface, cradle immense stores of carbon within their depths. In these sun-dappled wetlands, more carbon is sequestered per acre than in the tallest forests or the deepest oceans. Yet the bog's influence does not end with carbon alone. Their saturated soils cool the air above, shaping local climates and nurturing unique webs of life. Through the slow release of water, they temper floods and droughts, buffering the lands beyond their borders. In the silent heart of the bog, an ancient pact endures, one that regulates the planet's pulse breath by breath, season by season. Here the world's climate finds balance, held steady by the quiet persistence of moss, water and time. Beneath the tranquil surface of the bog, danger often arrives in silence. Not all threats to these ancient wetlands come from the obvious or expected. Sometimes the greatest perils are carried on the wind in the talons of a bird or within the drifting seeds of a distant plant. These are the invaders, species that do not belong, yet find their way into the delicate tapestry of the bog. A single seed, light as a whisper, settles on the spongy moss. It sprouts, grows, and soon an unfamiliar plant spreads its roots, crowding out the native sedges and mosses. With each passing season the invader thickens its hold, drawing away precious water, shading out the sun and altering the chemistry of the soil. The ancient balance begins to tilt. Mosses, once rulers of the bog, find themselves pressed to the margins. Frogs and insects that depend on the native plants grow scarce. The silent invader, indifferent to the centuries-old pact of the Mire, reshapes the land in its own image. Yet even the strongest invader can be humbled by nature's raw power. Lightning forks across a summer sky, igniting a blaze on the bog's edge. Fire, rare but mighty, sweeps across the peat, eating through moss and leaf alike. Smoke rises, and with it the stored breath of centuries, carbon released in a single, searing rush. Elsewhere storms gather in the distance. Torrential rains pound the bog, flooding the landscape beyond its capacity to absorb. Water, once a gentle guardian, becomes a force of destruction, tearing away layers of peat and uprooting the plants that anchor the mire. In the aftermath, pools widen and the surface sags, leaving scars where life once thrived. Invasive species and nature's fury, each, in their own way, test the resilience of the bog. The struggle is ancient and ongoing, played out in shadows and silence. For every threat there is a response, woven into the ever-shifting story of the mire. Here survival is not guaranteed, but it is fiercely contested, root against root, storm against soil, in the hidden heart of the world's wetlands. Beneath the mossy surface of the bog, where silence reigns and shadows dance, lies a world of untold secrets. Here, in the heart of the mire, nature whispers its ancient tales to those who listen. Recent advances in science have begun to uncover these hidden stories, revealing the bog as a living library of Earth's history and a crucible of innovation. In the depths of the waterlogged peat, unique microorganisms thrive, their existence a testament to life's adaptability. These tiny architects, unseen by the naked eye, weave a complex web of interactions. By breaking down organic matter, they play a pivotal role in the carbon cycle, locking away vast amounts of carbon dioxide and methane. New discoveries have shown that some of these microbes possess the ability to generate energy in ways previously unknown, hinting at potential breakthroughs in renewable energy sources. Among the twisted roots and submerged logs, ancient plants have developed extraordinary adaptations. Some have evolved to extract nutrients from the nutrient-poor environment, while others have formed symbiotic relationships with fungi, creating a network of mutual support. These botanical marvels offer insights into sustainable agriculture and resilience against climate change. In the murky waters, rare species of fish and amphibians navigate their labyrinthine world with precision. These creatures have evolved specialized senses to detect the faintest vibrations and chemical signals, guiding them through the dense vegetation. Their unique adaptations inspire biomimetic technologies, where engineers and scientists look to nature's designs to solve modern challenges. Above the bog's canopy is a mosaic of colours and textures, where mosses, lichens and carnivorous plants coexist in delicate balance. The sundew, with its glistening, sticky tentacles, captures unsuspecting insects, turning the bog into a living laboratory of evolutionary strategy. Studies of these carnivorous plants have led to breakthroughs in understanding nutrient cycling and ecological interactions. In the stillness of the bog, sound waves travel differently, creating an acoustic environment unlike any other. Researchers have discovered that the bog's unique soundscape can influence animal behavior, with certain frequencies promoting communication and others serving as warnings. This acoustic complexity offers new avenues for studying animal communication and environmental monitoring. The bog's surface, though seemingly unchanging, is a dynamic interface where water, air and earth converge. Here, the interplay of light and shadow creates microhabitats that support diverse life forms. Photonic structures within certain plants and insects manipulate light in ways that inspire advances in optics and materials science. As we delve deeper into the mysteries of the Mire, each discovery adds a new layer to our understanding of this enigmatic ecosystem. The bog, once seen as a stagnant and inhospitable place, now emerges as a vibrant and dynamic world, teeming with life and innovation. In this silent realm, nature's ingenuity knows no bounds, offering lessons and inspirations that reach far beyond the Mire.